Today I will show you my project STM32 as Modbus server through this chip W5500. It's a Ethernet chip actually, and my board is actually STM32 F5507. And for the connection to each other, I will be use protocol SPI. And first of all, I connected to my chip external ceramic, and also I'm using in this project. Actually, it's related with the Modbus library. Modbus library using own prepared tasks, and for the RTOS, we should give to the RTOS time-based source. In that case, we are using timer number 7. Next things, it's connectivity. In connectivity, I use SPI2. In chip, we see that it's pin PC2 and PC3. It's for MISO-MACI, and chip selection is PC4. PC5 is SPI reset, and SPI2 chips clock source. Actually, it's PB10 pin. Most important things, it's only 3 pin. But Ethernet chip required also additional 3 for the how to say, for more appropriate using. USART is just for my testings. We cannot pay attention for that. And I added to my project FreeRTOS. It's MCSV2. And actually, I nothing changed here. There is zero change, just default things, and we have one default tasks. I will show how we are using this default task. Next things, Ethernet chip actually required first things. It's required this structure. If you are open the declaration of the structure, we will see that first it's MAC address of device. You can generate MAC address from the gathering any random MAC address from the internet actually, and we need to implement our source IP address. It's 4 byte for the implementing, and subnet mask. A gateway, if you are using gateway and we go to the routing to another subnetwork, actually DNS, we are not using DNS here. And last thing is DHCP mode. We can waiting that DHCP server will be give to us IP address, or we will be implementing a static IP address. As you see in my project, I implement static IP address, and we implementing here that IP address will be static. This MAC address I get randomly from the internet. There is a lot of actually sites when they're giving such kind of things, and of course masks is 24. And gateway, I implemented a gateway number, but in reality we are not using we are not using any gateway and routing. We will be working only in the one subnetwork. Next thing, it's SPI structure, SPI2. These things actually already followed through our IDE. It's a default task, as I say, we are using in the future. And next things, it's a library related with the Modbus. In the Modbus library, we should define it. Next things, it's what kind of position we'll be using for our devices. In that case, it's Modbus slave. In TCP meanings, it means that it's a server. Next things, it's TCP hardware, timeout, and ID it's number 1. register, 16-bit register we are using. It's a holding register in meanings of Modbus. And I created, I already created array with Modbus data. It's I give them 60 register to 16 bit 16 byte. Yeah, next thing is Ethernet parameter, as we already created these things. And next things, port. And after all of that, first of all, we run Modbus init. Next thing, it's two important self-defined function. And first things, it's chip select fc func. If you go in here, we will see that it's standard function from the Visnet conf c. It's actually this library came from the from Visnet delivering with chip open source library. Which one next? Okay. Next, it's implementing two important things: how we are connecting our Visnet chip with STM32 through the SPI protocol. And for the delivering to the library of Visnet, we are using two self-defined function. First of all, first things, it's W5500 read buffer and W5500 write buffer. It's how SPI transmit and how SPI receive. I using how protocol, but if you want to more complicated and more accurate, you can write own function for the transmitting and receiving via SPI actually. And which one is next? After defining these things, after defining these things, a library of Modbus starting two tasks. It's actually one task. It's related to the or Modbus master or Modbus slave. In our case, it's Modbus slave. And that all. In the end, there is another function. It's Modbus start. In Modbus part, it's only understand which type of Modbus we are using and starting this task in RTOS. Here we go. Yeah, and there is a callback function, of course, and but most of the case in main purpose in this video is just showing how it's worked. And first things, I want to start Wireshark for the showing how our packets going through the Ethernet. And we are choosing our Ethernet adapter. Next thing, we should find out how we gather information from some simulator of Modbus client, and we will use Modbus pool. Here my definition is safe ID. You see that safe ID here it's 1. Yeah, and here we will be also using her. We will be using function number 3 is holding register, read holding register. Start from 3, and I implemented only 3 or 4 register. We will read only 2, from 0 to 2. Next, it's connection, and we should implement our IP addresses as writing and setting here. You see that we are setting IP addresses and that ports number 502, standard port protocol for Modbus, but you can change it from this structure, your standard port. Okay. Maybe we should rewrite our chip with this project. Let me check. Yeah, it's downloaded. Try pinning again. Nothing. One and 11. Yeah, here we go. We have ping with them, and yeah, I see MP protocol is working. And next thing is trying to simulation. Yeah, here we go. We see there is some changing numbers, figures, and these things changed from default tasks, and I just increasing my register after 2 seconds, 3 register actually. And also we see that there is exchanging between my device and my simulations, and we can see, stop and see what happened. First thing, it's sending information from the client that that he want to read to register from the server, and server answered to them. Same identification actually, protocol identification 0 for some Modbus TCP. Length 7, unit education 1. We implemented that our indicator of our devices 1. 2 register, it's register 1 and 0 and 1, and two numbers, 2 figures, what we get. Everything is work. And that's all. Now in this project we are using two main libraries. First library, it's VisNet library with 5500, and second thing, it's Modbus library that I'm getting from the GitHub.